In this class, we discuss about the solution or evaluation of double integration, which is from your university paper, and this is very important problem of double integration. Okay, here the problem is evaluate double integration over R box x plus y dx dy over the rectangle R. This is equal to 0, 1 and 0, 2. The rectangle is the range of x from 0 to 1 and the range of y is 0 to 2, where box x denote the largest integer not larger than x plus y. Okay, now we first draw a rough sketch of this rectangle, which is given by this is 0 to 1, this is 0, this is 1, and this is 1, x equal to 1 and x equal to 0, that is y axis, and this is 0 to 2, that is y equal to 0 to y equal to 2, y equal to 2, right? So we draw the rectangle as like that. Okay, now our integrand is box x plus y. Now box x plus y, this is equal to, if x plus y is greater than 0 and less than 1, okay, or greater or equal to 0, less than 1, and in this case the box x plus y, this is equal to 0. This is the property of greatest integer function. And in the second case, if x plus y less than 2 and greater or equal to 1, then this is 1, and in the third case, if 2 less than x plus y less than 3, okay, then this is 2. This is the value of box x plus y. Now here we draw 3 parallel lines. The first line is x plus y, this is equal to 1. The second line is x plus y, this is equal to 2, and the third line is x plus y, this is equal to 3. Why x plus y this is equal to 3, the x plus y this is equal to 1, x plus y this is equal to 2? Because if we draw a line here, this point is 1, 2, and if we put x equal to 1 and y equal to 2 in x plus y, box x plus y, then the value is box 3, so this is 3. So we draw the line x plus y equal to 3, and this line must be of the from this, okay, this is 3, 0, and this is 0, 3. And now we draw the line x plus y, this is equal to 2. X plus y, this is equal to 2 means this is 2, 0, and this is 2, 0, sorry, this is not 2, 0, this is 0, 2, okay, and this is the second line. And the third line is, this is 1, 0, and we draw the line as, sorry, this line as 3 are parallel, this, and this is 0, 1. Okay, we divide the whole range, that is R, into 3 regions. The first region is triangular, this is R1. The second region is R2, and third region is R3. Okay, now we integrate this as, this is double integration over R box x plus y dx dy, and this is equal to integration, double integration over R1 box x plus y, this is dx dy. The second is double integration over R2 box x plus y, this is dx dy, and the third is double integration over R3, this is box x plus y dx dy, right? And in the first range, that is in R1, this is R1, here we get box x plus y, this is equal to 0, so we put here this is equal to 0. And in the second, box x plus y, this is equal to 1, so we put this is equal to 1, and in the third case this is equal to 2, we put this is equal to 2. Okay, now we set the first region R1. Here we see that the value of x is from 0 to 1, and in the second range also the value of x is from 0 to 1, and in the third range is also 0 to 1. All the value or all the range of x in three regions are 0 to 1. So we put here the value of x, this is equal to 0 to 1, this is also x equal to 0 to 1, and in the third integration this is also x equal to 0 to 1. Okay, now we find out the range of y in the first range or first region R1. If we draw a strip parallel to y-axis, okay, this is parallel to y-axis in the region R1, then we see that the base is y equal to 0, and the end point or end of the range is this is equal to x plus y equal to 1, so y equal to 1 minus x. So the first integration, the range of y is y equal to 0 to 1 minus x, right? If we draw a strip parallel to y-axis here, this is the strip in the region R2. So for the region R2, the range of y begin from y equal to 1 minus x and ending in this is y equal to 2 minus x. So the range of this y, this is equal to 1 minus x to 2 minus x, and in the third, this is the parallel strip parallel to y-axis, and the last is this is equal to y equal to 2, and the first is y equal to 2 minus x. So the range is y equal to 2 minus x to 2. Okay, clear? These are the range of the three integration, and we get the total region R1, R2, R3, that is the total region R, and by integrating we get this integration must be 0 because the integrand is 0, and the second integration is integration x equal to 0 to 1, and the integration is y, the range is 1 minus x to 2 minus x dx, and the last integration is integration 0 to 1 and 2y, and the range is 2 minus x to 2 dx also. So we get integration 0 to 1, this is 2 minus x minus 1 plus x dx, and the second is integration 0 to 1, 2 into 2 minus 2 plus x dx, and this is x cancel out, so 1 dx, so this is x, range is 0 to 1, plus this is 2 into 2 to cancel out, this is x square by 2, and the range is 0 to 1. So we get this is 1, and also from 2 into half, this is 1 plus 1 plus 1, so the value is 2. Okay, so we get the double integration, and the value of this integration is